First up in this question, we're asked to derive the change of base formula. So x is equal to log to base b of c. Express c in terms of b and x, or we can rewrite this as b to the x equals c. Just like log to base 10 of 100 is 2, that's in log form. You can rewrite it in exponential form as 10 squared equals 100. The base to the power of this thing over here is 100. And now we want to get log to base a, so let's take log to base a of both sides. Log to base a of b to the x is log to base a of c. Bring the x down using the third rule of logs. And therefore x is equal, remember it's equal to log to base b of c from before, but now it's also equal to log to base a of c over log to base a of b. And there we have it, our change of base formula for logs. Now we're going to be using this formula a lot in the remaining questions. And I'm going to go through each of these in probably two ways. First of all, like the most efficient way, and then the way that I did it, which, okay, I'm doing it in real time. You don't always, as long as you get to the answer, sometimes that's enough. And then you can look back afterwards and reflect and think, oh yeah, that would have been simpler. Note, we must not start with the thing we're trying to prove. It's actually possible to start with false statements and derive true statements. So you can't start with something, get something that you know is true and say, yep, that's it. You have to be careful. You can do it if you think about the if and only if relationship. If one implies the other and then it implies it back. But here's an example of a false statement implying a true statement. -3 equals 3. Square both sides. 9 equals 9. Okay, and the fact is that it's not an if and only if relationship. We can square this way absolutely fine, but we can't go backwards. That's just not possible because you get a plus or minus going on. So let's start with the thing we know, pi squared is less than 10. Okay, and the most efficient thing to do is to take log to base 10 of both sides. And although you don't normally write to base 10, because here we're using lots of different bases, I'm going to go with it. We can write that down. We can do that. We can maintain the inequality because log is an increasing function. It's not like it goes down or up again. It's so if this first statement is true, then if we take logs, it's still true. That means that 2 log to base 10 of pi is going to be less than 1. Okay, now this is the bit I didn't think to do. Actually, we could look at the left-hand side just in isolation and see if we can combine it to something that looks a bit like this. And therefore, let's get the base 10 formula going on. It's going to be 1 over log to base 10 of pi over log to base 10 of 2. That's using the formula from above, plus 1 over log to base 10 of pi over log to base 10 of 5. Now I'm doing 1 divided by a fraction, so I can just keep change flip and just swap them around. And then we can add the fractions together. And I can combine these using the first rule of logs, the addition rule. So it's going to be log to base 10 of 10 because I times them together. And that is just equal to 1 at the top. So we're basically there. It's going to be a positive number. So 2 is going to be less than 1 over log to base 10 of pi. And I've just shown that that is equal to this. So using star, let me just see how they wrote it. Okay, they wrote it the other way around. we're going to have 1 over log to base. We could just say result follows, or we could write it down. And this limit could be greater than 2. Nice. Now this is how I did it. I started with, again, pi squared less than 10. And then I decided to take log to base 2 of both sides. And I imagine this is how whoever came up with the question sort of did it. They just came up with an inequality, played around with it until they found a good result. I mean, I could be wrong, I don't know. This doesn't seem like a result that's been an important result that's been known for centuries or anything. But in any case, so we've got log to base 2 of pi squared is going to be less than log to base 2 of 10. So 2 log to base 2 of pi is less than log to base 2 of 10. Just playing around with logs here. 2 is less than log to base 2 of 10 over log to base 2 of pi. Right, now we could split that log to base 2 of 10 into log to base 2 of 2 plus log to base 2 of 5. Nothing's stopping us doing that. And then separate the fractions. So we're going to get 1 over log to base 2 of pi, which we can see is here. And, if we're just playing around with it, yeah, that looks quite nice. Plus log to base 2 of 5. Okay, and then we can change the base on the fraction on the right. So 2 is less than. So I'm now going to change log to base 2 of pi to log to base 5 of pi over log to base 5 of 2. And this here is going to become log to base 2 of 5 times log to base 5 of 2 over log to base 5 of pi, which actually simplifies. These two multiplied to give 1 at the top. We get 1 over log to base 5 of pi. And so finally, 2 is less than 1 over log to base 2 of pi plus 1 over log to base 5 of pi, and we're done. Let me just return to that result that I just said. I just said that this was equal to 1. And that is true whenever you basically have the same thing, but you swap the bases around in there. And we can actually come back to this result here. So it must be from this result that log to base a of c is equal to log to base a of b times log to base b of c. So if I let a equal 5, b equal 2, and c equal 5, for example, then I will get log to base 5 of 5 equals log to base 5 of 2 times log to base 2 of 5. And we see that this here is 1, and that is proof of my result. And you can say actually if it will always be true basically if you just have like if you just swap them round and times them together, you'll always get 1. On to the next question. So first up, a really concise way of doing it. I'm gonna write it as log to base 2 of pi minus log to base 2 of e, separating it, is greater than a fifth. We know that that is true. And then I want ln pi, so I'm going to change the base. So it will be ln pi over ln 2. And then I'll do the same over here to make it consistent. So ln e over ln 2. We can then multiply through by ln 2. So ln pi minus 1 will be greater than a fifth ln 2. And we've got ourselves an inequality for ln pi. Just need to now deal with the ln2. Remember, we've got this. So what I can now do is, well, I want ln2, so I can again just take ln of both sides. Ln of e squared is going to be less than ln of 8. And that means 2 ln e is going to be less than, well, this is ln of 2, sorry, it's a blank for a moment, ln 2 cubed. Now ln e is just 1, so 2 is less than 3 ln 2, and therefore ln 2 is greater than 2/3. So because that's true, because ln pi is greater than 1 plus 1/5 ln 2, we can replace this by a smaller amount and it will still be true. Because if we have something like 1 is less than 3 and 3 is less than 4, then this implies that 1 is less than 4. Okay, it just follows as a result. So it's a similar sort of thing happening here. Ln pi is greater than this, which involves ln 2. Ln 2 is bigger than 2/3, so therefore ln pi will be greater than 1 plus 1/5 multiplied by 2/3, which is 2/15. So ln pi is greater than 15/15 plus 2/15, and therefore ln pi is greater than 17/15. Nice. The way that I did it, or actually tried to do it, it turns out, was very similar. I've in fact, going back through it, found a flaw in it. So I'm going to discuss it because, like, first of all, it's important to show that there's often more than one way to do it. But actually, it's also good to talk about where things can go wrong in proofs. And I've looked through it and I think I have made a mistake. And there's nothing wrong with the one above. And yeah, it's really nicely written out. We've replaced that. And yeah, this is going to be quite a key talking point, really. Because ln 2 is bigger than 2/3, then I can replace it here by 2/3, because the thing on the left will still be bigger than the thing on the right, because the thing on the right is even smaller. I suppose you could even, if you wanted to, say that this here is going to be itself greater than 1 plus a fifth times 2/3. That's probably a nice way of showing it, because ln 2 is bigger than 2/3. I can just replace it, and then the thing in the middle must be bigger than the thing on the right, and then I can just get rid of the thing in the middle to create that inequality. But if it was the other way around, if it was ln 2 is less than 2/3, and I couldn't jump to the conclusion that I did, and this turns out to be the flaw in the method that I'm about to show you. So I think I'm just going to have to abandon it once we found the flaw. So log to base 2 of pi minus log to base 2 of e is going to be greater than a fifth. What I did is I did change the base for this one, so ln pi over ln 2, but I kept the log to base 2 of e as it was, and then I added it onto both sides. And then I went with the e squared is less than 8, and I took log to base 2 of both sides. Which seemed to make sense at the time, because then I can simplify that 8. I'm going to get 2 log to base 2 of e is less than 3. So log to base 2 of e is less than 3 over 2. But that's where I went wrong, because then I said I could replace this by 3 over 2. So ln pi over ln 2 is greater than a fifth plus 3 over 2. But that is not necessarily true. I think it turns out that it is true in this case, but it's not necessarily true, because this thing here is bigger than this thing here. So we can't be sure. Like, there's going to be a point where, if we made it 5 over 2, then it wouldn't be true anymore. So I can't use the same logic as before, and actually I need to abandon the method here. I'm not going to try and make up another argument. This one is definitely like a lovely way to do it. But I just wanted to talk about like problems you can get with inequalities, and yeah, I'm quite didn't expect this to happen when I'm taking a different base, that the proof wouldn't work out, but that is a problem here. Ready? Let's do part 3. Okay, we're trying to prove that this is true. So it makes sense, I think, to start with the pi squared inequality and do ln of both sides. So ln pi squared will be less than ln 10. We can bring the 2 down and divide by it, so ln pi will then be less than a half ln 10. Now let's change the base into base 10. So it'll be log to base 10 of 10 over log to base 10 of e. And that's what we've got to try and figure out over here. Let me just rewrite it. Log ln pi is less than a half times 1 over log to base 10 of e. Okay, so e cubed is greater than 20. Let's take log, log to base 10 of both sides. Log to base 10 of e cubed is going to be greater than log to base 10 of 20. That means that 3 log to base 10 of e is going to be, see that 20, we don't really want 20, but I got a 2 here. So let's change it into log to base 10 of 10 plus log to base 10 of 2. So that means log to base 10 of e is going to be greater than 1/3, because I've just divided through by 3, 1 plus log to base 10 of 2. And then because log to base 10 of 2 is greater than 3 over 10, then log to base 10 of e is going to be greater than 1/3, 1 plus 3 over 10. We've managed to get it as a fraction. So 1 is 10 over 10. We're going to get 13 over 10, 13 over 30. Actually, what that means is that 1 over log to base 10 of e is going to be less than 30 over 13. When we take the reciprocal in an inequality, assuming they're both positive, you can do it. Then you just swap the sign around and obviously flip them both around as well. And that means that ln pi, okay, because this is less than 30 over 13, then this thing here is going to be less than a half times 30 over 13. And so ln pi is less than this as well. And that leads to our result. Ln pi will be less than 15 over 13. I took a slightly different approach to this. Again, I'm going to talk about it. It's a little bit messy with my solution. I was kind of doing logs all over the place in different corners and trying to piece it together. So forgive me if this is not a really smooth solution. But I did start again with ln pi squared equaling ln 10. So ln pi is a half ln 10. At that point, I thought, okay, I want to somehow get ln 10. So I could see a 20 there, and I decided to do ln e cubed is greater than ln 20, and therefore 3 is going to be greater than ln 2 plus ln 10. And then that means that ln 10 is going to be less than 3 minus ln 2. And I put that in. So apologies, I've just realized that should have been a less than. So if ln 10 is less than 3 minus ln 2, then ln pi is going to be less than a half times 3 minus ln 2. So I've basically dealt with that one, and now I can see the log to base 10 of 2 in there. So we can change the base. Ln 2, and I'll just deal with the ln 2 by itself at the moment. That's going to be log to base 10 of 2 divided by log to base 10 of e. And then I did all the stuff we did up here to get log to base 10 of e. Here it is. So piecing it together, we have ln pi is going to be less than a half 3 minus log to base 10 of 2 over log to base 10 of e. Now log to base 10 of 2 is greater than 3 over 10. So ln pi is going to be less than a half 3 minus 3 over 10 times 1 over log to base 10 of e. I should probably just simplify this like we did before again. So it was 13 over 30. So now I can replace this one because log to base 10 of e is bigger than that. 1 over log to base 10 of e is less than 30 over 13. And therefore, we're nearly there. It's a bit messier, isn't it? Because I'm kind of just all over the place, but it's going to get us there. A half 3 minus 3 over 10 times 30 over 13. The 10 and the 30 are going to cancel. This is going to become 39 over 13. And I'm going to be minusing 9 over 13. That's 30 over 13, divide by 2, 15 over 13. No flaws in the method this time, just doing it in a slightly different way. Very similar, to be fair. Okay, this video has been a lot longer than I expected because I talked about different methods, but I hope it's been insightful, not just to give how the answers did it, but to talk about how I did it, and in case of part 2, how actually there was a flaw in it. And I talked about other ideas such as, yeah, making sure you don't start with the statement you're trying to prove because a false statement can imply a true statement. Anyway, it's a nice question, and I hope you enjoyed it as much as I did. Well done.